Up next, we'll be looking at some two-variable inequalities. Information that you need before carrying on. Remember that anytime that we have a less than or greater than sign, we're going to use a dashed line to indicate that the line itself is not a part of the solution. And then anytime that we have a less than or equal to, greater than or equal to, we're going to use a solid line because that's going to indicate that the line is part of the solution. The first problem that we've got here involves graphing a linear inequality. So we're going to use a graph to find the solution of the system y is greater than 3x minus 1. So with inequalities, the first couple of steps are just like equations. We're going to go ahead and identify the y-intercept, which is -1, and put a point there. Then we've got a slope of 3, so up 3 and right 1. And then we've got to determine, are we going to use a dashed line or a solid line to connect those 2 points? Since we've got a greater than sign, we're going to use a dashed line for those 2 points. Once we've done that, we've got to figure out which side of this line are all of the solutions on. So to do that, we're going to use a test point. Now, the best test point to use, if possible, is 0, 0. It's going to make it easiest to do what we need to do. If 0, 0 isn't available, then use something like 0, 1 or 1, 0. Anything that involves a 0, just because the 0 makes the math a little bit easier. So what we're going to do is substitute 0, 0 in for y and x. So we get 0 is greater than 3 times 0 minus 1. 3 times 0 is 0, minus 1 is -1. 0 is greater than -1. That is a true statement. Since we've got a true statement there, that means that the shading goes on the side with the test point. The test point is true. So that means that we're going to shade to the left of our dashed line. The next problem, we're going to work out the same way we did the last problem. First, start by identifying the y-intercept, which is again a -1, and then the slope, which is 3, again, so we're going to go up 3 and right 1. Take a look at the sign that we've got. We've got a less than or equal to, so that means we're going to use a solid line to connect those 2 points. Once we've got that line drawn in, we're going to choose a test point. Again, 0, 0 is the best one to use. Plug those numbers into the original equation, or inequality. So we have 0 is less than or equal to 3 times 0 minus 1. Again, 3 times 0 is 0, minus 1 is -1, and we get 0 is less than or equal to -1. This is a false statement. So this means that all of our solutions are on the opposite side of the line from the test point. The test point is not a solution. So we're going to shade everything to the right of the line. The second question involves us using a linear inequality to solve a word problem. You're at the fair and you have $15 to spend on tickets. Small rides cost 3 tickets, large rides 5, and the cost of a single ticket is 25 cents. How many small or large rides can you ride? Now you notice that we're going to use a first quadrant graph on this because we can't have a negative amount of tickets and we can't have a negative price. So what we're going to do is we're going to say that x is equal to the number of tickets for a small ride. Y is going to be equal to the number of tickets for a big ride. And we can spend up to $15 or 4 tickets per dollar. And the linear inequality that we're going to get for this is that we can do 3 times small number of tickets plus 5 times the large number of tickets is less than or equal to 60 tickets, because we can do 4 tickets per dollar and we have $15. So with this, we can use our intercepts or change the equation to slope-intercept. I'm going to go ahead and use the slope-intercept to solve this. So we're going to take 3x plus 5y is less than or equal to 60. We're going to subtract the 3x over. Once we've subtracted the 3x over, then we're going to divide everything by 5. That leaves us with y is less than or equal to -3/5 x plus 12. So in this case, we've got a y-intercept of 12 and then our slope is negative 3 over 5. And you can see that what happens is when we end up working this all the way down, we get that the next, or the x-intercept is at 20. So we're then going to draw in a solid line, because the solid line indicates that we have the $60 exact, or the 60 tickets, or the $15 exactly to spend. And then we're going to try a test point. Test point, again, we're going to use 0, 0 because the origin is available. And you can see we've got 0 is less than or equal to negative 3/5 times 0 plus 12. Negative 3/5 times 0 is 0, plus 12 is 12. And we get 0 is less than or equal to 12, which is a true statement, which means that the test point is part of our solutions. So we're going to shade everything underneath the solid line. In problem number 3, we're going to combine what we know about graphing inequalities with absolute value inequalities. So use a graph to find the solution of the system. 1 minus y is less than the absolute value of x plus 2. So isolate y, and we're going to subtract 1 from both sides. That leaves us with negative y is less than the absolute value of x plus 2 minus 1. We have to divide out a negative 1 from both sides. So that's going to leave us with y. Don't forget to flip your sign. Since we're dividing by a negative, the sign goes from less than to greater than. So y is greater than negative absolute value of x plus 2 plus 1. Now the negative a means that our graph is going to open down. We need to determine the h value, and in this case it's going to be negative 2 because inside of the absolute value we have x plus 2. Then our k value is 1. So we've got a vertex of negative 2, 1. Once we've established that vertex, we choose 2 values on either side of the vertex. So I'm going to choose negative 4, negative 3, negative 1, and 0. And then we're going to substitute each of those values into the equation for x and figure out what is the resulting y value. So when we plug in negative 4 for x, we get a y value of negative 1. Negative 3 gives us 0. Negative 1 gives us 0, and 0 gives us negative 1. At this point, we have enough information to create an XY chart, which you can see here, and then we're going to go ahead and plot those points onto our coordinate plane. Once we're done with that, we can draw in our lines, and we know that these lines are going to be dashed because we have a less than sign. Again, choose a test point. The easiest test point to use is 0, 0. And then once we plug in 0 and 0 into the original absolute value inequality, we get 1 minus 0 is less than the absolute value of 0 plus 2, which gives us 1 is less than the absolute value of 2, or 1 is less than 2. This is a true statement. So what we're going to do is we're going to, again, shade everything above the lines that we've created. All right, so in this last question, we're going to try to create an absolute value inequality based off the graph that we're given. So the first thing you want to do to accomplish this is to go ahead and write out the vertex or general form of an absolute value equation, which is y equals a times the absolute value of x minus h plus k. And we can see that the graph opens up, which means that we're not going to have a negative a value, so there's no change. Then we check the slope. The rise is 1 and the run is 1. So again, 1 over 1 is 1, so there's no change to a. The next thing we do is we check the vertex, and the vertex of this graph is at 3, negative 2. So we're going to substitute 3 in for h and negative 2 in for k. So we get y equals the absolute value of x minus 3 minus 2. Then we're going to take a guess as to the inequality sign. Since this is opening above the graph, I would guess that our answers are greater than that line. So we're going to try that out and see if we get a true statement when we do the test point. So we've got y is greater than the absolute value of x minus 3 minus 2. Now we choose a test point, and again 0, 0 is available, so let's use that. Now because 0, 0 is not in the shaded region, then what we should get as the result of working out the inequality is a false statement. So we plug in 0, 0, So 0 is greater than the absolute value of 0 minus 3 minus 2. We get 0 is greater than the absolute value of negative 3 minus 2. 0 is greater than 3 minus 2, and then 0 is greater than 1. This is a false statement, which means that the solution that we came up with, or the inequality that we came up with, is the correct inequality.